Hi, thank you for joining the session. I'm Bülent Özden, a computer engineer and currently Common Voice Turkish language representative. I wanted to share the knowledge we accumulated in the last year while working on Common Voice Turkish dataset. Turkish has been an under-resourced language and the dataset is problematic in many aspects. There were individuals recording, but no language community, so we wanted to volunteer. Most of the work I'll be presenting will relate to Turkish, but these can directly be applicable to other languages. I will try to keep the presentation simple, not academic or very technical, except some pointers. Let me state our most important finding first. You should take care of your dataset, or it most probably will get biased, and bias is a bad thing for machine learning. As part of the introduction, I'll try to emphasize some hand-picked information to show what is important. One must realize that the Common Voice processes are like a conveyor belt in a factory. It consists of two main parts, text corpus and voice corpus, which are both fed into AI training. And each part has two sub-processes. The colors here indicate the easiness of the sub-process. Light green means easy, red means tough in terms of work needed. Like in a factory, if one process fails, the production rate or quality drops. For example, your dataset might become biased. Therefore, as I mentioned before, you need to take care of your dataset, monitor it, dedicate some time, and find a crowd, as this is a crowdsourced project. So, if you cannot find the crowd required, you may find yourself in a position where you are recording and validating many sentences. And don't expect quick results. It will take time. It is a marathon. Your alphabet is important. It should be the same throughout the pipeline. Conversational text, speech is preferred in the text corpus and it must be CC0 or public domain. These are hard to find, but being public domain also means that you can modify the original. Common Voice is a general purpose dataset. Although it started with Mozilla Deep Speech, it can be used with many models, so we can relax the rules set previously by Deep Speech. Common Voice dataset is not a clean dataset. It is not recorded in a studio environment. With all different devices and background noises, it is already somewhat augmented. This might be important to know while training your AI. By default, Sentence Collector uses English rules, but you can define your own rules via pull request in GitHub. The default English rules limit the sentences to 14 words. There is no hard limit on the length of the sentences, but you should try not to go above 100-110 characters. It becomes hard to read and error prone. Also, currently the recording is limited to 14 seconds. Some slow speakers might hit that limit. Deep learning models are black boxes. Resulting AI is the least interpretable among alternative AI models. You feed the data and test the resultant AI. It is mainly data-driven, and therefore it can easily get biased in an uncontrolled crowdsourced environment, which happened for Turkish. In Common Voice, bias can arise from many places: gender, age, accent, low number of speakers, or a single speaker recording too much, low number of sentences recording too many times where AI gets biased to that vocabulary. Ideally, you will need equal distribution for best results, so you need to know the dataset and take care of it. If the dataset gets contaminated or unbalanced, you have two options. Post-process the dataset and remove the contamination, which requires a lot of work, or take corrective actions and rebalance it in the next dataset. What is your goal for a working voice AI? How much data is needed? It depends on the application and your corpus quality. These are the numbers given on Common Voice website. Let us do a simple calculation. If you can get 1 hour validated recording each day, it would take more than 27 years to reach 10,000 hours. That much might be required for English, but fortunately we other languages have transfer learning, where we can use pre-trained models of English as a starting point and train more rapidly with much less data on more common hardware and with lower carbon footprint. In our marathon, we will reach all these milestones, train our AI, measure the performance with character error rate and word error rate, implement it in an application and test it in the wild. How much data will you need? That can only be answered after you reached your specific goal. You want to start a language or get your hands on your orphan dataset? You need at least 5,000 public domain sentences. You can extract them from old works which became public domain, but they must have current vocabulary and be conversational. Or just open a chat with the community and converse. You can add these sentences through Sentence Collector. You need to translate 75% of the user interface on Mozilla's translation tool, Pontoon. Afterwards, you request your language in Discourse or GitHub. We've been lucky for Turkish as we already had a started dataset. We translated the remaining, but you also need localization. For localization of language-specific examples and rules, you need to work more. For example, I listened to thousands of sentences and took notes on common mistakes, generated examples specific to Turkish before translating these on Pontoon. While doing it, keep the list large. Two lists for text corpus and voice corpus will be ideal. I summarized all the information I collected or generated on the Turkish sub-discourse. These will be very handy for your campaigns. It is easier for people to understand by examples. There are many resources, and if you are actively working in a language community, you might want to know all these information. Main Common Voice pages, Sentence Collector, Pontoon, Discourse forums, Matrix chats. If you will work with Cookie STT, go there and learn. And if you program, use GitHub, post issues, and PRs. Some additional random points. You need to be a native language speaker to guide. Ask for a sub-discourse, become a translator on Pontoon. But beware, you need to dedicate some time. Regular people will not come to Discourse Matrix, and Common Voice Backbone does not provide tools for building a community, so you may need to build it elsewhere. Regular people will not read technical jargon or long information. You might need to re-summarize the existing summaries. Time, duration values on Common Voice website are approximations. There are no real statistics yet. Volunteers must be 20 years or older or must have consent. There is a staging server to check translations. Metadata for datasets under Common Voice repos are helpful. Common Voice Utils repo is very helpful if you want to start training an AI. Okay, you started to work on your language, but you need to get volunteers to donate their time and voices. During the pandemic era, we could only do social media campaigns. But what will be your campaign goals? Would you just say, come and record? To determine your campaign goals, you need to know where you stand, so you need to analyze your dataset. Let us do a simple analysis. Get your latest dataset, expand it, and find the tab delimited files. You will see the validated and invalidated ones along with the other which are not fully validated or invalidated at that time. Train, dev, and test files are used in AI training. They will be a subset of the validated. Reported are those sentences which are reported during recording, listening by the volunteers. Examine your files for the following. I used Excel for this. How is diversity? Will it probably be biased when trained? Are people recording too much? Did some sentences got recorded too many times? You can go ahead and check more, also listening to a sample of the clips. Check the reported ones for your future text corpus. These are my findings in version 7.0 Turkish dataset. As you can see, the data is concentrated in one demographic slot, young males. Recordings by male voices are 11 times more than female voices. It is obvious that the dataset is biased to male voices. Same for the age. Most data comes from young people. Probably most of the languages will have similar status to a degree. As you can see, another peak is under blank. These are people recording without registration or logging in, or not prefer to give their demographic info. Although this is not good for AI training, this is a fact with current privacy laws and rules. You may like to emphasize the importance of the demographic information in your campaigns. One other problem with Turkish was the text corpus. Until version 6.1, there was only one text corpus added at the start of the project. SE times with 5077 sentences. These were translated news from Balkans with many proper names in Macedonian, Serbian, etc. And of course, they are not conversational. Although the number of voices increased in time, these sentences kept being recorded over and over with different voices. This would certainly bias the AI. In early 2021, we could add some new text corpus, hoping to remedy this and added much more in the second half. If we dig deeper and get a distribution of recordings per sentence, you will see these multiple recordings. Sentences recording only one time are most probably from the recently added text corpus. On the other hand, the default corpus creator program, which creates splits for the training, will take one recording per sentence to prevent sentence vocabulary bias. So, for version 7 dataset, only 1/3 of the already small data will be used in training, unless you create your own training splits. When we look at the distribution of recordings per person, things get more interesting. First of all, although the dataset download page states that there are 960 voices, the actual number invalidated is 851. Secondly, around 2/3 of people just visited, recorded a couple of sentences and went away. This is important for your campaigns. You need to make them record more and get into the community. Third, there are some people who recorded many sentences. They are young males, of course, and this will make the dataset more and more biased. We will see their biasing effect in the training results in the next part of the presentation. Now we know that the health of our dataset is not good at all. In our campaign, we tried to correct it both quantitatively and qualitatively. We have low text corpus and low number of recordings, and we want to increase them both. To prevent further bias, we first set a rule and asked people to record minimum 100, maximum 300 sentences. This means we expected 1 to 3 hours of their volunteer time. We designed the campaign to reach female voices. As we are not young anymore, our friends are mostly over 40 also, this was a plus. During the campaign, we also trained some AI and recognized that a single young male with accent drops the performance of the AI considerably. So we raised the expectations to 1,000 plus recordings and invited some people to balance this individual. We designed a multi-channel social media campaign to reach our goals. Facebook as a community base and to provide guides, YouTube for video guides, Telegram for instant support, plus Twitter, Instagram, and LinkedIn for announcements. We've got a domain name for future work and used shortened links to get click numbers where appropriate. Prepare your slogans, designs and messages, teasers, technical information, feedback from the campaign, dataset and training results. This one is a call for female voices. This one is for New Year celebration. Adapt these for your goals. And most importantly, you should have prepared new text corpus resources before the campaign. Do simple math to find how many you will need for your goals. We prepared these offline with our core group, checked every sentence 3-4 times. We pre-analyzed these resources and randomly mixed short utterances with longer descriptive ones before posting. For example, the left one here is Turkish proverbs. The right one here is from a book for Sabahattin Ali. We monitored the advances daily and fed the system with text corpus when needed. These are the green columns. It took 1 month to prepare all these, and we started the campaign on the 1st of November. We were thinking about a month, but the dataset release date kept pushing further and we pushed more. You can see the results of our campaign efforts, meaning social media posts, as red peaks. You can also see that we tried to keep validation, the blue lines, in pace with recordings. Otherwise, it would be impossible to keep up. So at the end of the year, we got this. On November, our goal was 100 to 300 recordings per person with white posting. After mid-December, we started to work with small groups to reach many more. This is also by the end of the year. As you can see, we had a big jump, more than 100% increase, although we could not reach our initial goal of 100 hours validated. As of this presentation recording, we see more than 65 hours of validated recordings. We were not that successful with the voice diversity though. Number of volunteers are better than if we left the dataset alone, but not enough. We cannot see the diversity changes yet, but if we look at the first 20 people in the Hall of Fame, we can have an idea. Female voices has been around 6% in the last dataset. We can see that it will be more balanced in the next dataset. We hope we could get a better training result with new sentences, female voices, elderly voices. Let me give you some pointers. Widespread posting is good for creating awareness about the project, but may not result in recordings. For us, it has been better when we asked our friends and relatives one by one. If you can build 3 to 5 person groups and support them directly, you will get best results. They will record and validate in their close groups. It's hard to overcome the social media algorithms. We found ourselves liking, sharing each other. We've got best response from Twitter by reaching local AI data science related groups, but of course this is not enough to reach common population. One last thing, you must be prepared to validate many recordings to check for problems and give one by one technical support if necessary. Most common problems we faced are the following. Microphone related problems such as bad cracks or low recording levels. Registration login problems, especially for elderly, non-tech savvy people. And problems caused by WebView type limited browsers in mobile apps. You cannot record in a WebView, so you need to ask people to copy-paste the link into a browser. This is a bummer for a social media campaign, of course. In a nutshell, social media did not work well for us, but it is the only means to reach large crowds. We must rethink our approach in later campaigns. In this part, I want to give a basic introduction to voice AI training and our findings for Turkish. These experiments are carried out after we started the campaign and took about a month with learning and debugging. Our experiments are based on the technical paper by Tyers and Mayer published on April 2021, which analyzed many low-resource languages systematically using version 6.1 of the dataset and using Coquille 093. They had 3 runs. First, a short training with defaults to build a baseline for acoustic model. Secondly, a parameter sweep run to find the best parameters, followed by a longer training to reach a better acoustic model. Third, addition of a language model. I will not rephrase the information which is already in that paper, but give you what I changed. In addition to these 3 runs, I had to add another 4th, as you will see. With the low resource in hand and with default splits, Turkish had high word error rate even with the language model. I started with version 6.1 to get at least similar results with this paper and then extended it to other datasets. My goal was to form a baseline for the next dataset release, on which we worked really hard, with all the analysis and campaign I explained. As I wanted to replicate the technical paper, I used Coquille, which is the successor of Mozilla DeepSpeech. Coquille can run on low-end devices like Raspberry Pi or Android, produces smaller models, and has real-time inference using only CPU. At that time, Coquille version 1.0.0 was out with pre-trained English model from version 7 dataset. My 4th run is based on Coquille version 1.1. You will really need a powerful Linux machine with powerful GPUs for training. My Windows machine was a no-go and I had to eliminate more costly alternatives. I decided on Google Colab free tier for preparation and trials, then moved to a pro account for the real runs. The interactive notebook-based interface on Colab was really good for experimenting and learning. As it was a roundup, I also needed more space on my Google Drive. Although there are example notebooks in the Coquille repos, they do not work out of the box. Coquille prerequisites require you downgrade. Because finding the solutions took some time for me, I want to mention them here. First, you need to tell Colab that you want to use version 1 of TensorFlow. Secondly, you need to switch to CUDA 10.0. Fortunately, it is already installed in Colab and you just need to link to it. Third, you need to install the required TensorFlow GPU version. Otherwise, you will be stuck with CPU, which will be much slower. Let me explain the whole workflow for Coquille transfer learning first. I put the Google Drive in the middle to show the data flow. There are 4 main actions. 2 of them, importer and corpus creation, can be run offline. They do not require GPU. Acoustic model and language model creation need to use GPU, especially with larger datasets. First, we create language-specific alphabets and importer script, and we already have our Common Voice dataset. We feed them to the importer. The importer converts MP3 and TSV files into WAV and CSV, which is required in the following steps. As we will be using transfer learning, we also need English breakpoints, which is provided by Coquille. We feed them to the training and get best Turkish breakpoints. We test it, repeat the process by fine-tuning our parameters if necessary. Then we export it into a TensorFlow-like model. For language model, we first find public census resources. We combine them into a corpus for further processing. I used CanLM Scorer, which generates a 5-gram language model. This model keeps probabilities of a word following another. The process needs some parameters which can only be guessed though. Therefore, deep speech or cookie has an optimizer which repeatedly guesses some values and shows you best results. Then you can use the KNLM scorer again with these best values to get a more optimized language model. And of course, you need to test the results. We finished the model generation and want to use it in an application, which includes an inference engine. We move the TF Lite model and our scorer to the device where the application resides. These are the import results for each dataset. Some of the clips are skipped by the importer, those which have characters not existing in the alphabet, clips longer than 10 seconds. You can see the average clip duration is around 4 seconds, but there is also an anomaly in version 7 where clip duration is shorter. This was alarming. Our first roundup aimed to match the results of the aforementioned paper. We used 25 epochs with 32 batch size as the original. We got better results for version 6.1 dataset. The difference is because cookie version 1 is used, English breakpoints from cookie version 1 training is used, which are based on dataset version 7.0. It was interesting to find out that Turkish version 7 was worst performing dataset, nearly as bad as version 1, and best epoch was too early for it. Thus, a second alarm. In the second round, we used proposed parameters from the paper. These helped us a lot for the starting point. We keep the batch size as 32 again. As we saw that 100 epochs are not sufficient, we used 300 epochs with early stop. You can also see that we can directly access the Google Drive for the data. We saved all the intermediate results, checkpoints, exported models, etc. back to Google Drive. To overcome issues with Google Drive connection, we used shutil, flushed, unmounted, and remounted the drive to be safe, and ran the testing part separately using evaluate. As you can see, the loss function drops down very rapidly at the start, then searches for the minima. Whenever our dataset grows larger, we will experiment more with the parameters to decrease the training time. For the third batch, we added the same resources as the original paper to our language model. Then we used CanLM to produce a 5-gram language model with 500,000 words, which include a bit over 99% of all words. We saved this model and use it in all our runs. We added the optimization script to our pipeline, which was not used in the original paper. Here, you generate your scorer with some arbitrary values, run the optimizer n times to calculate better default, alpha, default, beta values, put best results found back into the scorer generation program to get an optimized scorer, and of course, test it with evaluate. It takes quite some time to process, but you will get a better language model and better test results. These are our final results for all dataset versions. On the left, character error rate. On the right, word error rate. As you can see, best results are for version 5.1, and in version 7, the performance drops considerably, although it had 50% more recordings. There had to be a problem. To find the reason, I had to go back to the analysis phase. I analyzed default splits in every aspect and found the following. Number of distinct voices in version 7 train set dropped considerably. There are no female voices in version 7 train set. All voices are male. So we were training with few male voices and testing with mixed voices. Digging deeper, I found out that a new young male volunteer with some accent recorded many sentences lately. That voice is prominent in both train and dev datasets, and the corpora creator that generates the default splits does not take any biasing effect into consideration. This is already an open issue in corpora creator in GitHub. When we saw this, we decided to update the campaign goals in order to balance male voices who recorded many. The proposed solution by Francis is as follows. One speaker only in one file, one sentence only in one file, multiple recordings per sentence by different people allowed. We applied this method and ran through version 6.5 and 7 datasets, taking 1 through 5 recordings per sentence, if it exists, of course, and tested the results. We used Cookie 1.1 and batch size 128 this time. By the way, the batch size is limited by your GPU, and it is better to use higher batch sizes in these ranges. It will run faster and it will generalize the voices better. When we take multiple sentences, mainly the train set increases. With 5 recordings per sentence, we almost get the whole recordings. As you see, we get more diverse voices and also female voices into training. These are our final results with alternative splits in word error rate. With version 7 and with 5 recordings per sentence, we could get the word error rate a bit below 29. Remember, in the original paper, this was around 57. Remember, we had these multiple recordings from the previous years where SE times text corpus was the only one. So the resulting AI would most probably bias to Balkan news this time. There is also the following question we have been discussing. Is it wise to have many recordings per person? We saw that if only a couple of people do many recordings, it will result in bias. We know it is best to have many people recording less, but what if we don't have them around? Isn't it better to make existing ones record more? A third question. How many recordings per sentence is best? Larger number would decrease the requirement for the text corpus, which is hard to find. Also, wouldn't having multiple speakers, genders, pronunciations for the same sentence be better? As a conclusion, some final words. Voice AI is a vast area. We only scratched the surface of it. But to do more in this area, we need a good working dataset. Our efforts as Common Voice Turkish volunteers will continue to focus on the betterment of the dataset. And we will also extend our knowledge to other libraries and models once we have a less biased dataset, hopefully this month. Common Voice is a great project for democratizing the voice AI. Although there are some shortcomings and needed features for general purpose use, it is the only large-scale multilingual open source voice dataset which also became a benchmark. So we need to thank Mozilla, Mozilla Foundation and the Common Voice staff for their work and dedication. The whole community around Common Voice and Cookie is great. If you get stuck, you will find your answers there. Thank you, community. Special thanks go to Francis, Hilary and Michael for their patience and their help in the last year. I also want to thank to my friends who helped most in our campaign, Tuğçe, Dilek and Mansur. And biggest appreciation go to all Common Voice Turkish volunteers for their participation. Our campaign happened during a socio-economic crisis in Turkey. In spite of that, you succeeded and pushed Turkish Voice AI to the next level. Thank you for joining the session. I hope it will be useful for your future work. If we have time in the questions and answers section, I want to present some slides on the new dataset and training results. Here are the updates with the version 8 dataset showing what we have accomplished. The problem with corporate creator continues. The train set has 13 distinct voices again, but this time gender distribution in the train set is nearly even. Secondly, we could get a more balanced dataset. We could lighten the biasing effect of young males. Female voices increased 3.5 times. Recordings from people above age 40 also have 3.8 times increase. On the other hand, despite our efforts, people without demographic info kept increasing. We think this is mainly caused by two things. A bug was introduced where demographic info got reset. We had server outages at the start of the campaign where people had to relog in many times. Some might be kept out. We calculated about half these can be corrected automatically. People without demographic info are in reality about 15%. If we compare the last three datasets, as you can see with the new added text corpus, which is more than 6 times, we've got much diverse sentences. That would make the default splits more usable. We could reach 53% in version 8. And by taking 2 recordings per sentence, it will become 77.5% of the dataset with minimized effect of Balkan news. Recordings per person data is not easy to change in short time periods. We have 308 new voices and we can see that nearly 20% of newcomers recorded less than 20 sentences, so more dedicated volunteers than before. We had some success in our target area, namely 300 sentences, but major data increase came from dedicated people recording many sentences. This was our second target. Here you see the increase in data in 3 groups. First group is the size of the text corpus, increased 6.5 times in last year. Second one is the number of clips validated and cleaned, suitable for training, increased 3.8 times. Duration increase is 3.2 times. Third group is sum of trained dev set sizes. This also increased 6.5 times. As you can see, we could keep the conveyor belt running without any bottleneck. The major jump is in the train set in the default splits, shown as the line and with the right vertical axis. Although the number of voices is as low as 13, the total duration of the train set increased from about 3 hours to more than 15 hours. As you can see, we could correct the performance just by balancing the dataset. In version 8 dataset, with default splits, we have better word error rate. Acoustic only model reached around 80.9. With language model, it became 38.7. We have just gained what we have lost. These are our final results with the alternative splits with error rate. In version 8, with 5 recordings per sentence, we could get the word error rate down to 65.43% with acoustic model only, 28.11 with added language model. Thank you.